let me start the
Yeah,
session
Mr.
now.
Ali, but
So
I
today
didn't get
topic is
the
vapor
notes yet.
compression cycle, and in vapor compression cycle we'll learn how we are getting the cooling effect, and this cooling effect can be used to cool the food products, and that we can call as a refrigerator. And the same cooling effect, if you utilize to cool the water, we can call water cooler, or else the same cooling effect can be utilized for or to cool the air. We can consider that as air conditioned machine. No doubt the capacities will different, but the concept or the cycle behind refrigerator, water cooler, and air conditioner is same. And the cycle is called vapor compression cycle, also known as basic cycle. So before starting vapor compression cycle, first you must know what is refrigerant. Okay, so but before starting this refrigerant, I'll play one small video clip to get some idea, because this topic, as I said, is this is important, because in chapter 5 we are dealing with the different type of systems, and if you want to learn the systems, you must know this vapor compression cycle. So let me play one small video clip. In this video clip, you'll get the idea about this cycle, just idea. Detail I'll show you with the line diagram. After playing this video, just have a look.
System activated by a compressor will be described first. It is divided into the high and low pressure sides. The high pressure side is that portion of the system through which the refrigerant travels under high pressure. This side starts at the discharge valve of the compressor and includes a condenser, the receiver or storage tank, and the liquid line. The low pressure side is that part of the system through which the refrigerant moves under low pressure. This side starts at the expansion valve, which divides the high and low pressure sides and includes the cooling unit or evaporator, the suction line, and the suction valve of the compressor. The compressor is essentially a cylinder in which a piston works. This is the course of a refrigerant through a typical compression cycle. The refrigerant, in the form of a gas under low pressure, is drawn from the suction line into the compressor. The gas enters the cylinder through the suction valve as the piston moves on its downward stroke. When the piston moves upward, the pressure and temperature of the gas rise. The gas is compressed and is finally pushed through the discharge valve into the condenser. The refrigerant enters the condenser as a high-pressure gas, and its temperature is higher than that of the air or water cooling the condenser. As heat flows from the gas to the cooling agent, the gas condenses, changes to a high-pressure liquid, and passes into the liquid receiver or storage tank. From the receiver, the high-pressure liquid refrigerant passes through the liquid line on its way to the cooling unit. The high-pressure refrigerant must now be reduced to a low-pressure liquid so that it can evaporate at a low temperature. The refrigerant passes through an expansion valve which divides the high and low pressure sides and controls the flow of refrigerant into the cooling unit. The refrigerant enters the cooling unit under a reduced pressure caused by the suction stroke of the compressor. It evaporates, absorbing heat from food in the refrigerator and providing what we know as refrigeration. The refrigerant, now a low-pressure gas, is drawn through the suction line back to the compressor, completing the cycle. This, then, is the cycle of changes of the refrigerant as it moves continuously through the compression system.
think you got some idea. So let me start with the refrigerant. Okay, so we are dealing with as per the course title, we are dealing with the designing, drafting, installation and estimation. We are not talking about the service and maintenance. But if you involve in service and maintenance, you need to go through detail about the refrigerant, the type of refrigerant, the chemical properties, then chemical formula, all about the refrigerant, because mostly in the breakdown you are dealing with the refrigerant charging. But as per the course title, we are not offering the service and maintenance, but we'll talk about the basic, because as a design engineer or a site engineer, you should know the basic about the refrigerant. Okay, so the some basics of refrigerant is given. So what is refrigerant? You can read here. It's a heat carrying medium during the cycle. It's a heat carrying medium during the cycle. Which cycle? Vapor compression cycle, which we are going to learn. Which rejects heat at condenser and extract heat at evaporator. Both are heat exchangers. One is used to reject the heat, and whenever rejection of heat, the vapor will change to liquid, and whenever extraction of heat, the liquid will change to vapor. Okay. Next, if you refer any RNAC book, you'll find the list of refrigerant. You can go through when you have time, and already as a mechanical you know different types of refrigerant. But what are the types of refrigerants? Classified into three categories. It's given here. First is CFC, second is HCFC, and third is HFC. So if you talk about the history of this refrigeration, before 19th century, the people are using natural refrigeration, like cutting the ice from the polar region and using this solid carbon dioxide, nothing but dry ice, and some natural sources. And that was difficult. It's not easy using the natural resources for cooling. So in the beginning of 19th century, many scientists developed many systems, but you know, the scientist called Willis Haviland Carrier, means Willis Carrier, who got the commercial success on his system, and we are calling father of air conditioning. At the time, the CFC, not exactly at the time, after some modification, when the refrigerant is used, the CFC was popular, and CFC was popular last 20 years back also. But after some time, when the scientists come to know this chlorofluorocarbon CFC is affecting the ozone, and you know the function of ozone. Ozone layer is used to filter the UV radiation, and because of that we are safe. The radiation is not directly affecting to our body. But if suppose damage of ozone layer O3, direct radiation from the sun onto your skin, that may cause skin diseases. And in New Zealand, Australia, and some Western countries, it is already affected. So when the scientists come to know this CFC, using CFC will affect the ozone, so what they did, they decided not to use this. And in present market, the CFC is totally in almost all the countries, because it will affect the ozone layer. And at the time, the best example was R12, and this quote R12, 502, etc. is given by the first company in the refrigerant, means first big company in the refrigerant, called Freons. To avoid confusion in communication, to place the order, to handle, etc. Instead of reading the chemical name, chemical formula to place the order, they have given this code. So R12 means you'll find the chemical name, chemical formula, etc. So this is just for information what we are learning. CFC is now not in market. HCFC, the new option is available. So HCFC, hydrochlorofluorocarbon. This also contain carbon. This also contain chlorine, but compared to CFC, less. It's approximately 8 to 10%. But this also affect to ozone layer. So as per scientists, some say for next 5 years we can use this, or as per some opinion it can use up to 15 years, next 15 years. And some companies in Gulf, in Western countries, they are not using even HCFC. As per my knowledge, the Zamil company, they are not using HCFC, and Train they are still using, Daikin they are not using. So HCFC also in future the people will not use, the companies will not use, and still many companies they are not using this. So the example of HCFC, present people are means in companies they are using R22. May ask in interview, you can highlight this. Next we have HFC, hydrofluorocarbon. This hydrofluorocarbon is eco-friendly, environmental friendly, no chlorine content. So we have HFC, then why the use of HCFC? Because handling HFC is not easy. So the initial cost of the system increases with HFC. That's the reason still we are also using HCFC in market. Okay, and the best example of HFC, hydrofluorocarbon, which is used in market, you can highlight R134A and also highlight R410A, which is commonly used in actual practice. Okay. The information is given in the next page. You can go through this for interview point of view, like name. You see tetrafluoroethane, and the properties are also given. And recently this question asked in interview, cylinder color code for this 134A, it's light blue. And similarly information is given for 410A. You can go through this. This is for interview point of view. Next, so the liquid or the gas which is flowing inside the cycle is what? Refrigerant, right? And refrigerant in short we can call heat carrying medium. For what? For vapor compression cycle. So now we are ready to deal with vapor compression cycle. This is interesting and simple. So with this line diagram on screen with the orange and blue color, let me explain this, how we are getting the cooling effect. So what are the major components? The major components are, you can see, start with the compressor in order. First is compressor, and second is condenser, third is expansion device, and fourth is evaporator. Okay, so we start with the compressor. So what happened inside the compressor? Listen on screen, online classroom. Inside the compressor you will find the refrigerant in gas state. Remember, in compressor you'll find the refrigerant gas state. Why? Because the compressor is designed to handle the refrigerant only in gas state. Any liquid in the compressor means compressor will damage. And one more point, gases are compressible, no? Not liquid. Okay, so you'll find the refrigerant in gas state in compressor. And when you switch on the compressor, for example, when I apply the electrical energy or connecting the turbine, whatever, means suppose switch on this compressor. So what happened? The name compressor will give you the idea. Mechanical people know this. So compressor means what? Which is used to compress. So what happened when you switch on the compressor, means refrigerator or AC, you'll find the same components in both. At present I'm considering this cycle for air conditioning. The same is used for refrigerator and water cooler also. You need one example you can take. So we are learning air conditioning, so I'm taking this cycle for air conditioning, not for refrigerator. But if you are understanding easy with the refrigerator, you can take the example of refrigerator also. So refrigerant in compressor in the liquid form. When you switch on the compressor, what happened? First of all, volume. When you compress something, volume will decrease, right? Volume decreases. And what happened to pressure? Pressure increases. And you know this pressure is directly proportional to temperature, na? Already we defined the temperature. Temperature is a function of molecules. More temperature means more velocity. This temperature is the function of velocity of molecule. Velocity of molecule means pressure, right? So pressure is directly proportional to temperature. So if the temperature increase, pressure increase, temperature also will increase. Actually our requirement to increase the pressure to run the cycle. But these are both are directly proportional, so temperature also will increase. So with the increased pressure and temperature, the refrigerant will come out from the compressor in this line. You see high pressure, temperature, vapor. Means in vapor form, na? Means gas form. Say for example, say 55 degrees centigrade. 55 degrees centigrade is a high pressure for refrigerant. Why? Because maximum refrigerant boil at minus temperature only. Just now 134A. 134A start boiling at minus 26 degrees centigrade only. So it positive temperature it is in vapor only, na, with a high pressure. So for example, say 55 degrees, and this is just an example. This temperature will vary from system to system as per the capacity or as per the type of refrigerant. Okay, this is just example. Say 55 degrees centigrade in vapor, and that this refrigerant will allow us to pass to a heat exchanger called evaporator, condenser. This is called heat exchanger in general, but why we are calling condenser? Because the refrigerant is supplying in as vapor, and when it is flowing inside this, what happened? We can use the fan here. you can add this fan with the motor. So forced convection, and I'm drawing this line. This is HS means high side, and this is LS low side. So this fan will take the air from outside and throw on this coil. Suppose outside temperature say 45 degrees centigrade, and this refrigerant temperature 55 na. So as per second law, as per second law of thermodynamics, heat transfer from high to low. So what happened when the air is thrown on the coil, the refrigerant heat will extract by the air and air come out as a hot air, and this condenser is designed by the manufacturer to pick the heat equal to what? Equal to latent heat. And whenever latent heat means change of phase, right? So what we learn basics we'll use now. So when the refrigerant is flowing, it will reject definitely the heat equal to latent heat. So when it is coming out, it will be in liquid form. So that's the reason this is called condenser, because refrigerant get condensed na, vapor to liquid, condensation, right? So this is called condenser. But you see, change of phase means at constant temperature. Temperature is still same, 55 degrees centigrade. But this 55 degrees centigrade, vapor to liquid, no doubt, change of phase. But you know this change of phase at same temperature. So this 55 degrees centigrade is not enough to get the cooling effect. So what we'll do, after this compressor condenser, the refrigerant will allow to pass to one more device called expansion valve or expansion device or throttling valve. So here I am writing point 1 and point 2, and I'll draw this. Suppose this is the line. In the video you'll find the spring type coil na? The same, small narrow section, the same here. Say this is 20 mm and this cross section say 3 mm. So compared to 20, 3 mm is very small, so that the tube, small narrow cross section tube in the video is an expansion device. And what happened, you see, here is a point 1, here is a point 2. You can relate point 1, point 2. So point 1 means refrigerant in liquid na, and it is flowing with a very small narrow cross section. And here is a suction pressure. Why? Because you see at point 2 the compressor is running, so suction pressure because compressor suck, then compress, then supply. So at point 2 you have suction pressure. So here point 2, so we have suction pressure here, and when the refrigerant is controlled and supplying with a small narrow cross section, suddenly it will get the big area. Means from 3 mm again the refrigerant getting 20 mm area. So what happened? Expansion process take place. Expand hoga na? The expansion process take place. And whenever expansion process take place, what happened to volume? Volume increases. And what happened to pressure? Drops. And pressure is directly proportional to temperature, so temperature also drop. So at the outlet of this expansion device, means at point 2, you'll get cool refrigerant, say 15 degrees centigrade, 55 to 15, and 15 degrees centigrade is enough for cooling effect, for air conditioning, not for refrigeration. For refrigeration the case is different. So 15 degrees in liquid, and you see low pressure, low temperature liquid. So low temperature, low pressure. And I think one more point here, but before this, anything to discuss online or classroom? Compressor, condenser, expansion, before moving to next point. Anyhow, in this at this level, chapter 3, you are going to learn how the system works. But the actual components I'll show you in chapter 5. The appearance of actual component, how the compressor, how the condenser, how the fins, and what are the different systems. If you know this, then you can understand, and you can learn chapter 5. Okay. So don't worry, I'll show you all these components in chapter 5. At present, just understand how the system works. That's it. So here at 15 degrees centigrade, after losing the heat because of expansion process. One more law or one more condition. Water boil at what, 100 degrees centigrade, right? Everyone know this.
Sorry, I have a question.
Can you boil water at 50 degrees centigrade? First of all, yes or no? Can you boil the water at 50 degrees centigrade online? Yes or no? I'll write here yes and no. You can click on your answer. Click on your answer. Can you boil? No. Okay, one no. Other? Quick.
Boil, sir, we can boil.
So you said two people centigrade water boil. At what pressure? Yes, very good. At atmospheric pressure. If you decrease the pressure less than the atmosphere, you can decrease the boiling point. Not only for water, for any liquid, because the boiling point what we'll get in the chart is based on the atmospheric condition, atmospheric pressure. So 100 degrees centigrade water boiling temperature for water at atmospheric pressure. If you decrease the pressure, we can boil the water. In some application in industrial, they are boiling water at 5 degrees centigrade. Very cool water, but boiling. The pressure is so low. So it means that the boiling temperature, the boiling point can modify by controlling the pressure, right? So the same concept we are using when the refrigerant is coming out at point 2 is the 1 to 2, it is at low pressure and temperature, na? So low pressure means what? The boiling point also decreases. So means now the refrigerant can boil at low pressure also, sorry, at low temperature also, right? So this here is a concept. When the cool refrigerant with the low pressure and temperature entering in the evaporator, it is at low pressure means the boiling point also low. And when it is entering here, what we'll do, we'll use one more fan. This time this fan will take the air from the room. This is from the room air, say 30 degrees centigrade, and throw on this coil, and this is 15 degrees. So again heat transfer as per second law, high to low, na? So when the air throw on this coil, what happened? The air heat will extract by the refrigerant and air come out as cool and dry air. This dry you underline. I'll explain this dry after learning dew point temperature in psychometry chapter 4. At this level you will get the confusion, so I'll hold this. Anyhow, just write and underline this, but you can understand cool air, right? So you'll get the cool air. Why? Because the refrigerant will extract the heat, and refrigerant, listen, the refrigerant at low pressure, so it can boil at low temperature. So when the heat, when the air, room air heat is given to refrigerant, the refrigerant start boiling at the low temperature, and when it is boiling, it will extract more and more heat, and when it is coming out from the evaporator, it is in low pressure, low temperature vapor, change of phase. In condenser, liquid to vapor. In evaporator, vapor, liquid, in condenser, vapor to liquid. And evaporator, liquid to vapor by extracting the heat. Extracting the heat means it will cool the air. And again, the low pressure and temperature in the vapor sucked by the compressor, the cycle continues, right? And this cooling effect at present we are utilizing to cool the air. So it's air conditioner. The same cooling effect inside the refrigerator, you'll find that cooling chamber, that is a evaporator, or the same cooling effect can be used to cool the water, that is water cooler. So the source is same, but the applications are different, right? So in this way the vapor compression cycle works. Simple but very important. At the time of chapter 5 we'll use this cycle to learn all the systems, right from window to chiller. Okay, so if you have any confusion, you must clear at this level. Why? Because if you have confusion in this, then you cannot learn chapter 5. With this we did chapter number 3.